Hi and welcome back. I'm really excited to guide you through turning our scraper into an async scraper. We're gonna see a few things that may be a little bit surprising throughout this video, but generally, you're gonna see massive performance improvements from doing this. We're gonna start with re-implementing our functions in order to make them async. So, we're gonna have our fetch page and our get multiple pages in here. I'm going to go into the async request and just copy them because they're going to be exactly the same. That's the reason why we've covered these two functions, is in order to allow you to reuse them throughout any project. Of course, we've got a few imports missing, so let's make sure to import them. We no longer need requests, so we can get rid of that. We can import async IO, IO HTTP, async timeout, and time. Time is just for the timing. We can remove it later on if we want. Notice how we've got this requests page here. So actually, we do have this separate requests in there just to get the number of pages that we're going to request. Remember, we started at 1 and we got up till page count. So actually, I revert what I said earlier. We still need import requests. And that's totally fine. You can have synchronous code surrounded or joined by asynchronous code side by side. That's totally fine. I just forgot that we were doing this to get the number of pages. This is okay. You could potentially turn this into an asynchronous request, but because it's a single request that we're doing first in order to get the count, it doesn't make sense to treat this asynchronously. After all, it's just one request. You have to wait for it to finish before you can get the data. So there's no benefit from running one thing simultaneously as itself. So this is going to still be synchronous. That's okay. And then we're going to have our two functions here in order to fetch the page and get multiple pages. And then we can call them down in our loop. Notice how our loop is iterating over the page count, and then it's going to get each URL using requests. We no longer want to do this. We no longer want to iterate over the range and get each page. Now what we want to do is get all the URLs and pass them in to our get multiple pages function. So what to do is to copy this and put it in a list comprehension. Like so. And you can call them URLs, for example. Again, all we're doing here, and by the way, I'm going to close the sidebar just for your benefit there so we have a bit more room. What we're doing here is just putting this inside the list comprehension between the range 1 and the count. Exactly the same as we were doing here, but except we're no longer iterating over it, we're just creating the URLs. Then we're going to start a timer just to check out how long it takes. I'm going to do pages equal loop dot run until complete, get multiple pages with the loop that we'll create and all our URLs. We're going to create the loop at the top. That's just sort of the normal thing to do, create the loop at the top. We're going to say loop is asyncio.getEventLoop. That's all. Now we can use this loop to run things until they're complete. Okay. Then at the end, we can print that it took some amount of time. Print total page requests took time.time minus start. Okay. Now, these pages, what is the value of them? Because the loop has ran this thing here until it completed. This thing here returned an await of the grouped tasks. So what is the result? Well, fortunately, this works exactly as you would hope. These group tasks, which is this gather thing, then gets returned as individual elements in a list of the results of all the tasks that were ran. Notice how each task returns the response.status. So in this return group task, what we're going to get is a list of statuses for each page that returned. Okay, they could be in order, they could not be in order depending on how long each one took. Okay, so instead of returning the response status, we're going to return the response text. That's just the HTML contents of the page. But because this can take a while to download, IO_HTTP actually lets us await it so that we can suspend before we start downloading and resume once the download has completed. So really great stuff there. Now that we are awaiting the response text, these pages here are actually going to be a list of all the pages that we've downloaded using our tasks. So what we can do then is say for-page content in pages. And here is where we are going to create our all books page and extend our books list. So we're going to copy that there. And that's it. This is all we need in order to make this code asynchronous. Okay, so let's cut that off and run this and see what happens. Bringing back this sidebar here. We're going to right-click the menu and run it. And you can see what's happening here. It is not so fast. It is in fact pretty slow. What's going on? Google was so much faster. And you can see that they didn't all run at the same time. You know, there's one here that took 0.23 seconds, and then there's one here that says took 8 seconds. And you know, the first time I saw this when I was preparing the notes for this course, it actually took me a wee while to realize what was happening. I thought, why is one of them taking 0.2 seconds and the other one's taking 8 seconds? I thought, are we maybe running these not asynchronously? Are we doing something wrong? But as we've seen, we just literally copied what we did earlier that did work for Google. So this is the reason why we copy and pasted this code, just to make sure that it was all correct. Sometimes it can be a bit difficult to debug and find out the issue with asynchronous code, just because, you know, you're suspending, you're resuming many times throughout various functions, especially if you have something like 50 functions that we do here, all suspending and resuming. It can be difficult to debug if you use PyCharm as debugger. So it's easier to start simple, start small, like we did earlier on in our async request file, and then try it out with a larger thing. And the problem here is just that the books.toScrape server doesn't allow us to do all these requests at the same time. It just does them one by one. And it returns one by one. And because we've sent him 50 at the same time, hey, the first one's going to be quick. But then it's doing the first one. And when that's done, it does the second one. And so forth. So by the time it gets to the end, what you're essentially looking at is the sum of all the requests you've done. Each one takes around 0.23 seconds. So the first one takes 0.23. The second one takes 0.4, 0.6, close to 0.8. So forth. So it just gets added each time. You can see that it's returning them one by one. So this is a problem with the thing we're scraping, not with our code, which is a good thing. If you were to scrape a page that isn't a test page, something like Craigslist or Gumtree or John Lewis or some big reseller like that, but some big department store, you'll see that these will all come back at the same time. Okay. And if we change this to google.com again, just to go back to what we know, and we run this again, you can see that, you know, it's instant. They are all running at the same time. It's just that the other one, the other page doesn't let us get them all at the same time. So we're going to stop this. Remember to stop your programs when you're running in PyCharm. It can be something you forget. So if we were able to run our books.toscript.com asynchronously, you'd expect it to take around 0.3 seconds, 0.4 seconds in total. But because it doesn't, it takes much longer. Okay, that's just a limitation of what we're scraping, not of our code. I'm assuming that when you're building your own scraping projects, you're not going to be using this test scraper, this test website. You're going to be using a proper website, and that's almost definitely going to work just fine. I've tried it with a bunch of other websites, and they all seem to work okay. So that's it for this video. This is all you need to turn this into an asynchronous scraper. Remember, the majority of our code, creating the all books page, you know, and going through and parsing and stuff like that, that's instant. There's no waiting involved here. That's just Python doing work. There's no waiting for somebody else to give us things. The only waits are happening when we make the web requests And that's what we're running asynchronously. The rest of our code is running synchronously because it doesn't need to run asynchronously. It's really quick. There's really no waiting time. The performance here is not an issue. So that's it for this video again. Thanks for watching, and I'll see you on the next one.